Now let us start chapter 1 on the topic of Introduction to Process Simulation Tools, and we will be focusing on Expand Plus. I think with my explanation in the previous session, you should be able to get some idea about process simulation and computer-aided design. There are two outcomes for this chapter. First outcome is upon the completion of this particular chapter, you should be able to create a new Expand Plus simulation, and second outcome is to construct flow sheet, including adding blocks and streams, connecting stream, breaking or joining streams, labeling, and also numbering the stream and also the block. So there are some important elements in constructing the flow sheet in Expand Plus. So these are the steps that involve. Let's go through one by one. And we have to first create a new blank simulation, followed by enter the components, and then we should also choose and specify the property method. Property method over here is referring to thermodynamic model, like whether it's an ideal gas, whether it is obeying the model of Bain-Robinson, and etc. So this one we are going to have another separate session later on, right, before we start chapter 2. So after we specify the property method, then we have to enter to the simulation environment, then we create the stream in the flow sheet, and then we add the block. Then we can start connecting the stream and connecting the block from one to each other, and we have to finally rename the stream and also the block based on the convention that we should use for process flow diagram. So in order to do the flow sheeting, we have to do some revision on process flow diagram, especially on the convention that we should use to name the stream and also the block. Block over here is referring to the unit operation. This is the process flow diagram for the production of benzene via the hydro dealkylation of taurine. So if you look at here, we have taurine as the raw material, and hydrogen is used to hydrogenize the taurine, and the product will be benzene. Okay. So this is benzene. So I think you have learned the process flow diagram in your mass and energy balance subject. So I won't go through detail. It's just to remind you that the symbols that we should use for stream identification. Of course, if you use Expand Plus will have the same thing, but maybe the shape is a little bit different for different parameters. For example, over here we have the stream number. Normally they will put it in a diamond, and for temperature they will put it in a rectangle, and pressure it is put in the trapezium. So convention used for identifying process equipment. So general format is we have here XX dash YZZ A stroke B. So XX over here is referring to the equipment, the letters for the equipment. Say if we have compressor, then we start with C. Means XX over here is replaced by C. So if you have heat exchanger, then we use E. If we have reactor, we use R. And if we have pump, then we use P. Okay. Y here is designating an area within the plant. Say in the plant there are three main areas. We have area 100, 200, and 300. So Y here is referring to the area number. So it can be 1. Okay. The zigzag over here is referring to the equipment number in that particular area. Okay. A/B meaning the unit or the unit operation in the plant is having a spare unit. For example, we have pump, okay, say P101 A/B, then we have to know that that particular pump is having a spare unit in the plant. Okay. Spare unit is crucial because it is for the purpose of maintenance work. So once one of the pump required maintenance, then we have to actually off it for maintenance, and we on the spare pump. So the example over here I have actually extracted from the previous PFD. We have a T101. T is for tower. Okay? T101 meaning that this is the first tower in the area of 100. Okay. We have a P102 A/B. So as I mentioned to you, if it is with A/B, meaning the second pump in the unit area of 100 is having a spare unit, and say we have P301 A/B. This means that this is the first pump in the unit or area of 300, and the spare unit is also available. So in terms of stream numbering and also convention, so normally we number the stream from the left to the right. Okay. And utility stream, we should use a convention as given in the following tables. So for example, we have LPS means low pressure steam. Okay. MPS means medium pressure steam, and cooling water, we name it as CW. What else? Like fuel gas. Okay. If you need fuel in your plant, then you use fuel gas, so it is FG. If you need natural gas as your fuel, then you use NG. So I have actually tried to identify the utility stream from the previous process flow diagram. If you look at here, we have HPS, high pressure steam. Then we have CW, the cooling water. So meaning E102 is actually a cooler. So we have here E106, the medium pressure steam is used in E106, meaning this is a heater, and this is also the reboiler of T101. So since the diagram are small, so you know that process flow diagram normally is small and very packed and congested. So we will use some symbol or some flags to include the important information. Okay. For example, here we have the flag of rectangle and also trapezium. So 600 is referring to the temperature, while the 25 is actually referring to the pressure. Okay. And other than the process flow diagram, it must always come with this stream table to include the important stream information. So the essential information in the stream table include temperature, of course stream number. We include stream number, and based on the stream number we have the temperature, pressure, vapor fraction, total mass flow rate, total mole flow rate, and also the individual component flow rate for that particular stream. So this is the example for the stream table. Okay, assuming that the plant maybe is only having 10 stream, then for each stream you should have the essential information. Okay, as I mentioned in the previous slide, the other information like mole fraction and mass fraction of the stream are actually optional. So you have to now get started and practice using XPlus through Get Started Guide. So there is a guideline given to you with the name of Get Started Guide. You have to go through the guide and follow the procedure given in the guide. Okay. I think meanwhile you can also refer to my demonstration to get a better understanding. Of course, for the first time you follow the guide, but if you are familiar with the software later on, you can actually use your own method, develop your own method to get the simulation done faster. So I think that's it. I hope you can go through the guide and start practicing. Thank you very much.